Hi, welcome to the pre-calculus lecture series. And this video, we're going to cover the section 5.5. And this is the topic. We talk about the inverse trigonometry functions and what is their graphs looks like. And this is very, very important sections. And you need to kind of get very familiar with it, and because you're going to use it a lot in the calculus. Okay, so now let's go ahead and go to our lecture note and take a look at what is the inverse trigonometry functions. All right, so let's get started. Okay, so before we get started here, let's do a brief review and what we learned before about the inverse functions here, okay? So if you still remember, like in the previous, I think at the beginning of the class, when we reviewed algebra, so one of the things we talk about is the inverse function. So that means you have here, this is the x value, this is the y values, right? So here, so this type of the relations, so like every x value, you find a one value, and like this, right? So this is what we call it is a functions, correct? Okay, so that means for every of the x, and then you're going to have y's, right? So then this set here for the functions here, so the x is what? X is the domains, right? So it's this set. And then what is the y value? Y is the ranges here, right? So we said the inverse functions. What is inverse? Let's like go backward. So from y to x. So for every y value, I have x value. So I'm going this directions, right? So like this one here, I'm going this directions. And this one's here, I'm going this direction. And this one here, I'm going to this direction. So if I go from the y to x, so what do we call this? We call it F inverse. So we use the F negative ones here, call it F inverse. So for the F inverse, what is your domains here? So the domain, the range is going to be changed, switched, just like a function. So now y, because you go from y to x, right? So y is the domain through here, right? Then what is x? X is the ranges here, right? So that's what is the relation between the function and its inverse. And then we also say, in order for this like back relation exist, right? So from this point back to here, this point back to here, this point back to here. So one of the very important characteristics, what do we say here? It has to be a one-to-one relation, correct? Okay, so it has to be a one-to-one. That means what is one-to-ones here? So that means for every x here, you only have what? You only have one y values, right? So that's what we said. You have to have a one-to-one relation in order so to have what? For the inverse to exist, okay? So one of the common things we also talk about in there, we say, hey, we can use, we call this the horizontal line test. Okay, horizontal line. So I should say here, so for every x here, there exists one values also like if x not equal to xy not equal to x2 and then y1 not equal to y2. That means they cannot have the same value. So we say the horizontal line test. So like, for example, we say, for these functions here, like if this quadratic, for these ones here, right? Then if you put a horizontal lines here, we said for every x here, right? So for every x here, right? So so this x and this is x1, this x2. They give you what? They give you the same y values here. So if you have the 1, 2x given to the same one values here is not 1-to-1, then that means the inverse is not exist. Correct? All right, so that's why it's very important is this 1-to-1 relation is very important, right? Okay, now let's take a look at the sign. Okay, so before I write it down, what is the inverse sine function? So let's take a look at the signs here. All right, so like we did a graph before, so we know the sign is something like this. Right, so if you say this is pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi's, right? So here, this is 1, and this is negative 1. So sine is something like this. Oops, that's terrible. Okay, so sine is something like this here, right? Right, so if you want to continue, you can continue. Okay, so if this is the sine, so when you use the horizontal line test, all right, so if I use the horizontal line test, obviously sine is not 1-to-1 functions here, correct? Because you can, the different value can get the same y value. So obviously this is not a 1-to-1 functions. If it's not a 1-to-1, I cannot define the inverse. So in order to define the inverse functions here, so I have to pick the area, all right? So which is cover the whole range of the y, but it's also, this 1-to-1. So take a look at the sine, right? So this is the sines, right? So the original, the sine x, this is the sine axis here, right? So the original, the range of the sine is from where to where? From the -1 to 1, correct? Right, so that is because I'm bounded by -1 and 1. Then the ranges here for the sine, I'm sorry, the domains here for the sine is what? So the domains here is what here is the all real number, correct? So if you have all real numbers, then I know I cannot, it's not 1-to-1, so I cannot, find the, the inverse. So in here, I want to restrict it, I want to restrict it to my domains in a certain area, so it have the 1-to-1 relation. So here, that means, that's why the most important part for the trig function is here. You need to restrict your domains here. Okay, so make sure the way you restrict it, then the 1-to-1 exists. Okay, so also when I mean restricted, that means that the range has to be covered, the original ranges here, right? So I know the sine axis ranges from -1 to 1, and so I want to have a domain which can cover the whole range. So that's why in here I would say for the sine, I'm restricted my domain in here from the -pi over 2 to the pi. So because if I have this one from the -pi over 2 to the pi here, see what happens here. So this is my function of the sines, right? So from this function, it covers the whole range from -1 to 1. So you probably will ask, okay, if according to that, can I have a regions here, this part, right? Can I have the restrict my domain to this part? Because if you restrict your domain to this part, this will be your negative side. Then you say, okay, I also restricted to this part, then it will be here. So they still cover the -1 to 1. Can we do that? Yes, I guess so, if you want to do that, but the common practice, right? So, but for the common practice here, what we do here, we typical is like we restricted the domain to the, the negative pi over 2 to the pi over 2 areas here. Okay, so this is what I'm going to write it down. And so now you should be able to get a better understanding why I need to restrict that. Okay, so the first, let's try to write down the inverse function for the sine functions here, right? So what is the inverse here? Okay, so first things here, we say the inverse function of a sine is written as sine inverse. All right. And remember, the inverse is the opposite, like your domain and in here, right? The inverse, your domain and the range switches, right? So the inverse functions here is going to have a domain. That means cover the whole ranges here is the domain is what? -1 to 1 here. And the range, because you remember this is, we need to restrict it. So the domain become range, range become domain. And what? And the range is here is what? Is negative pi over 2 to pi over 2 here. This is super important, right? So a lot of students make a mistake is because of here, right? So because you need to restrict your domains here. So the way we restrict the sign, we put it in these regions here. Okay, so it's negative pi over 2 to the pi. So that's what we write it like this. We said sine inverse x equal to y. So basically it's the same way you will write as the sine y equal to x here. Okay, so sometimes the sine inverse also, you can, it's called, you can use a different name. You can set arcsine, all right? Okay, so that's another just terminology is called is the arcsines here, all right? So now let's try to re-emphasize what we have here. So make sure we understand that. All right, so this is my 1, 2, 3, 4, 1, 2, 3, 4. So this is a pi, this is 2 pi, this is 1, this is -1. So this was my original sine functions, right? Can continue going, right? So can continue going. So this is my sine functions, right? So this is x and y. So I will write is y equal to the sine x here, all right? And so remember, right, very important. So I will going to restrict it, the domains in here from negative pi over 2 to pi here, okay? So from negative pi over 2 to pi, that means I am only care about this part. Did you get that? Okay, so that means I'm drop, kind of restrict to this part. So that means instead of drawing the sine function like a repeat, right? So this is what is the sine I'm focused on, right? So this is 1, this is -1s, right? So this is the sine function, just like I highlighted here. So this is the sine function I'm work on here, right? So this is the y equal to what? This is y equal to the sine x here, but I'm kind of restricted domain to negative pi over 2 to the pi over 2, right? So because that is, because now you pass the horizontal line test, and then you can find the 1-to-1, the inverses here. Okay, so now what is the graph of the inverses here? Remember, inverses here is the switched, right? So that means my domains here will be 1, right? So this is 1, -1. The range become domains, right? And then the domain become what? Become ranges here, pi over 2, negative pi over 2, see here. So this is what my inverse function is going to look like. Okay, so this is what we call this y is equal to sine x here. So over the way, remember, like this is now be able to follow what we had in the before. So why is the graph look like this? Because it's going to symmetric to the this x equal to y, right? So that's why this one bend this way here. Okay. All right. So now that's a very important, that's why the restricted domain concept is so important here, right? Okay. So now we call this the cancellation rule, because if the inverse bump to itself going to disappear, right? So like in here, the sine inverse x here. Okay, so this one's here going to, just like we did before, this is the sine, this is the sine inverse, and this one will just be equal to x here, right? So for the x is from -1 to 1 here. This is the one. Okay, so the next one is here. Of course, you can put the sign outside and then the sign inside, right? So if you put it this way here, it will be equal to x, because we say this is the inverse, this is the right of original function. But because in order to define the sine inverse, my x has to be in where? Negative pi over 2 to the pi over 2, see here. So if you have something different, then this equality, then this equation is not going to be true, see here. All right, we're going to take a look at some examples here. Okay, so that means x has to be, okay, so it's so important, because that's why we say where you restrict your domains here. Okay, so now let's take a look at some easy examples here, right? So for this one here, let's take a look here, the sine, arc sine 1/2, right? So arc sine 1/2, that means what angle will give you 1/2, right? So that's what that means. So this is the sine graph. So back to the unit circle. So what is the angle will give you 1/2 here? Hi is the sum here, right? So it's a pi over what? So this is a pi over 6, right? Because it's a pi over 6, it will give you 1/2. Okay, so now, what is the value going to give you the negative 1/2? Remember, when you're doing the arc sine here, right? So I'm only restricted what? My domains here. That means I'm only care about is this part, right? So that's why I say it's important. So in here, that means what is the angles here is it has to be in here, right? So what is this one here? This is negative pi over 6, correct? You cannot say, hey, I'm going to here. This is negative pi, negative 1/2 as well, but I restrict my domains here. So my angles here is negative pi over 6. Okay, so now next things here, you say the arc sine is 3/2. Well, for this ones here, arc sine is 3/2. I know the sine cannot greater than 1. So this is 1.5. So I don't have such number. So this is not what? Not exist here. Okay. And now the problem number 2, this is the one. So you can use so this is a calculator problem. So you can try to use your calculator to see you can get the answer or not, okay? So make sure you set your calculator, okay? The setting here for your calculator, you has to set it at the radian setting. We're going to talk more about what is the radian inverse degrees, those things, in the next chapters here. So right now, set in the radian, then you use your calculator, you put the point A to the arc sine to see what is your calculator going to give you. So check it. So this one is supposed to give you 0.96141, pretty close to here. Then you put a 1/3 and try to check here. So this will be very close to, okay, so this one's here will be, okay, so this one here will be very close to what? 0.33984. So the purpose I put here is just want to make sure you know how to use your calculator, okay? Okay, let's take a look at example number 3 here. This is the one we need to be very careful. Okay, so first the sine pi over 3. Okay, so from the unit circle, I know the sine pi over 3. So this is the arc sine. Okay, pi over 3 is a what? It's the square root of the 3 over 2. All right, so now you want to see what is the angle will give you the square root of the 3 over 2. So this one will be what? It's a pi over 3. Okay, so this is just, you can cancel that out because this is a sine, this is a sine. Remember, we said what is the key things you'll be able to cancel out if this angle is what? This angle is between pi over 2 and the negative pi over 2. So for here, this pi over 3 is between. So okay, so that's why you can cancel that out. Okay, let's take a look at this one's here. All right, this is very important. So in here, don't say, oh, arc sine, I can cancel out. Okay, 2 pi over 3 is not in this range, so I cannot cancel that out. Okay, so now let's take a look at what I can have here, right? So the 2 pi sine 2 pi over 3, okay, based on the unit circle or the terminal point, this one is the square root of the 3 over 2. So you will have the sine, arc sine, square root of the 3 over 2, see here, right? Now you think about, between the pi over 2 to negative pi over 2, what the value will give you the square root of 3 over 2? What is that? It's pi over 3. Okay, so the answer for this problem is a pi over 3 here. Okay, so it's very, very important, right? This is the place the student make a mistake because they say, oh, inverse and you can cancel. No, because that's why we said the restricted domain is very important because the sine function is a periodical function. If you don't restrict the domain, the inverse not exists here. Great, good, okay, good. Now let's take a look at cosine here, right? So let's see, how do we define the cosines here? Okay, so for the cosine here, right? So first things here, let's take a look at the graph of the cosine, and then we can write the definition because cosine is what? Is a periodical function also, right? So cosine is a periodical function. So I know if you take a look at the whole domain, it is not going to have inverse because it's not a one-to-one here, right? So let's take a look at the cosine. So this is the pi, this is 2 pi. This is the pi over 2, this is 3 pi over 2, this is negative pi over 2. And this is 1, this is negative 1. Okay, so cosine is a graph like this, right? So if you want, you can continue. So like we say, because cosine is periodical, so it will not be able to pass the, it will not going to be able to pass the horizontal line test, right? So we need to restrict the domain. So remember, the domain we restricted has to cover the whole range. So I notice this is the domain I need to restrict it. Because in this domain, what happened to my cosine functions here? This is my curves, right? So it's a cover from the -1 to the +1. So that is why I can do like this, right? So here, this one's here, this is a pi. So this is x, this is y. All right, so here, this is ones, right? This is -1. So now what is my sine curves here? Sine curve is here, right? So cool, okay. All right, so that is the, what is my sine curves going to, because now where I am here, I'm restricting the domain in where. I'm restricting the domain from the here, right? 0 to what? 0 to pi here. Okay, so now let's try to write it out, right? So the inverse of the cosine functions here, right? So the inverse of the cosine function. Okay, so we is written as cosine inverse. Okay, so where is the domains here? The domain is -1 to 1 here. Then in here, where is the range of these ones here? Is from 0 to pi here, right? So very, very important. So very, very, very important. Okay. So this is 0 to pi, and very important here, right? All right, so now I can have the cancellation functions here. So I can say, so just like I wrote for the cosine, I can say it's a cosine inverse x. This will be equal to x. X is from -1 to 1 here, right? So this is the cancellation, the function and the inverse. Okay, so now if you put the arc cosine outside and then the cosine inside here, right? So this one, if you want to cancel out, right? So what you have to restrict here, the x has to match the ranges here, 0 to pi here, right? So like I said, it's different, right? It's different than the signs here. So this is very, very important, right? So that don't make the mistake. Okay, so let's take a look here. The first problem is here, find some of these examples here. So let's say, what is the value of a cosine 3 square root of 3/2? So remember, my cosine is only in this regions, right? So -3/2 is not negative. Square root 3/2 is what? It's a pi/6. Okay, now cosine 0, arc cosine 0. So what angle make the arc cosine 0? This one is pi/2, see here. Okay, so now in here, so we say negative, -1/2, arc cosine -1/2. So where is -1/2 here? Is here, right? So -1/2 is here. So what is the answer here? So that will be what? -1/2. So that will be pi/2 and what? Plus pi/what? Pi/6, right? So you will get 2 pi/3. Okay, so that will be the answer for the arc cosine. Okay, now let's take a look at these cancellations and things here, right? Okay, so for the cancellations, so the first things here, let's see here. Okay, so hey, this is the cosine. Oops. Okay, so here, take a look at this is the cosine, 2 pi/3. We say you can cancel out if this is in the, what we specified. So cosine 2 pi/3, right? So cosine 2 pi/3. So what is the cosine 2 pi over 3? This is between. So this angle is between what? So 2 pi over 3 is between pi and the zeros, right? That's what is the cosines restricted domains here. So since it is within, so this can cancel. So what is here is 2 pi over 3. Good. Okay, so now the next one's here. Let's take a look here. So this is the 5 pi over 3. 5 pi over 3 is a little bit bigger than the pi's here, right? So I cannot. So the first thing here, I need to evaluate what is the cosine 5 pi over 3. Okay, so cosine 5 pi over 3 is here. That means the angle is go all the way to here, right? So this is 5 pi over 3. So the reference angle is what? The reference angle is 2 pi over 3. So what is the cosine 2 pi over 3? It will be 1/2, right? So this will be 1/2 here, okay? So this will be the 1/2 here. Okay, and so this is a cosine 5 pi over 3 here. Okay, so the reference angle is 2 pi, and so now, okay, so I got so sorry here, so 5 pi over 3. Okay, so cosine 5 pi over 3. So 5 pi over 3. Oh, I'm sorry, I got it wrong here. So it's not in here. That's why. Okay, so 5 pi over 3 is all the way to here. All right, so okay, so the reference angles here. So what is the reference angles here? So the reference angles here is a pi over, so this is the reference angles here is a pi over 3. Okay, now much better. Okay, now it's also in the fourth quarter. So this is positive. So now I have a cosine negative, not cosine, arc cosine, the cosine inverse 1/2. So what is the cosine inverse 1/2 here? Is pi over 3 here, right? Okay, so because I need to make sure this is the angle back to what my restricted domains here. Okay, now let's take a look at the inverse tangents here, right? Okay, so the first thing here, just like we did before, let's try to graph the tangents, right? The tangent is a little bit different here because they have asymptotes here, right? Okay, so this is a pi over 2, this is a pi, this is a 3 pi over 2, this is negative pi over 2, negative pi. Okay, let's take a look at my tangent. The tangent is like something go like this. That is how they repeat, right? Okay, so if you want to go continuous, you can continue to go like that. Okay, so the same ways here, because the tangent is from negative infinity to the positive infinity. So I also is repeated, so it failed the horizontal line test, right? So I need to restrict the domain. So where going to be the good domain I restrict here? Yeah, here, from the negative pi over 2 to the pi over 2, see here. Because in this restricted domain, my tangent is going to cover what? The whole range is here from negative infinity to the positive infinity. Okay, so this is what is my tangents here, right? So this is the pi over 2, this is the negative pi over 2, right? Okay, so this is the restricted domain my tangent going to have, see here. Okay, so now let's try to write the cancellations here, right? Okay, so now the cancellation things here, we'll say the tangent and the tangent inverse x here. So this is equal to x because x is all real number. Now, if I have an arctangent in the front, then I have a tangent x here. Only if and only if I can cancel the cancellation for the inverse and the function itself. Only if this is x in where? Ha is in the what? Is in my, okay, so in here I shouldn't include this equal sign because it's undefined in the equal. So only if and only if, right? So this is my restricted domains, right? So be very careful, right? For each function, their restricted domain, decide what is the value of your, the inverse function. Okay, so now let's take a look at these ones here. Okay, so the arctangent 1, that means what is the value going to give the arctangent 1? Okay, go to your unit circle. What is that? It's a 45 degrees or is a pi over 4. Okay, next one here is what is the value going to give you the square root of the 3? So go to your, go to the unit circle. What is this one here? This is the pi over 3. So it's 60 degrees pi over 3. So arctangent 20s, right? So you can, so make sure you put this into the calculator. Okay, then you also the calculator's setting, make sure you put on the radians, right? So now this one's here, check you can get it. So it's 1.5208 something, okay? So that is for the tangent. So every one of them is the same here, all right? So now let's take a look at the remaining 3. So we're just looking from the graph point, all right? So the secant functions here. Okay, so this is my secant. Now from the function, I'm sure you're going to know what is the restricted domain is, right? So this is the 1, this is -1. So remember, oh, this is secant. Secant is the reciprocal of what? Secant is, oops, I got rid of all that. That is bad. Let's put it back. All right, so I put it back here. Okay, good. Okay, so this is the pi over 2 negative pi. This is pi, 3 pi over 2, the pi, 2 pi. Okay, so cosine is this way, right? Cosine, dun, 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 and this is a cosine. So I know the secant is the inverse of the cosine, so it's going to have what? It's going to have asymptotes here. So let's graph the secant function first, and then you will be able to tell me where is the restricted domains here. So if I go here, I have this, right? And then for here, I'm going to have this, and this, right? Okay, so now in here, so you want to, you want to cover the, take a look here, right? So the secant is from negative infinity to the positive infinities, right? So where will be the best, the domain to cover? So where is that? Where will be the best domain to cover here? It will be from where? It will be from here. It's pi to the 3 pi over 2 is a cover. So from the pi to the 3 pi over 2 is a cover these legs, right? And then I need to cover the top leg. So where is the top leg? So this is what? So this will be from here. I'm going to cover this leg here. It's a little bit different, all right? So we need to be careful. See here. Okay, so those are the restricted domains here, right? So in here, so if I have y is equal to the secant x here, right? So the secant x, so my restricted domain going to be what? I'm going to have two parts, right? X is from 0 to pi over 2, and x is from where to where? X is from the pi to where? 3 pi over 2, right? So be very careful here, right? So when you try to find the values here, right? So you want to, so for the second, if you cannot remember, just make sure you cannot remember the graphs here, okay? Let's take a look at the next one, is the cosecants here, right? Okay, so this is found, right? So let's take a look at cosecants here. Okay, so the cosecants here, right? So cosecant, okay, so this is my function. So this is pi over 2. So here, this is a pi over 2 pi, 3 pi over 2, 2 pi, negative pi over 2. This is 1. This is negative 1. All right. So cosecant is the reciprocal of sines, right? So let's do a sine. So this is my sine. Okay. So the cosecant, so let's do the asymptotes here. So let's graph it. So this is my sine. Okay, so the cosecants here will be the reciprocal, right? So that's why this will go like this, and this is go like this, and then this is go like this, this is go like this, that's right? And this one's here is go like this, all right? Okay, so now let's take a look here, right? So where is going to be my restricted domains here? Well, the first one's here. I would say, hey, I can restrict here from the 0 to 2 pi over 2. If I restrict it here, I cover this leg, right? I cover this leg. So I cover the leg, go to the positive infinity. Okay, so I need to restrict another one. Where I'm going to restrict it, go to the negative infinity. Hey, I'm going to restrict it here. All right, so this one's here going to cover these legs, right? Okay, so that's why. So for the y equal to the cosecant x here, right? So where is my restricted domains here? From the 0 to pi over 2. And what is the here is x is from the pi to the 3 pi over 2 here. Okay. And be careful about the, yeah, so the notation signs here, all right? So here, this is the, okay. So here I need to be careful about is like this one's here. Is the, cannot, the, when you go to the asymptote, you don't have the equal signs here, correct? All right, so the pi here doesn't have the equal sign here. I need to be careful about my notations here. So this is the pi. So the same here for the, oh, this one I take care of it. Oh, the only one I did not pay attention is this one. So cannot have an equal, all right? All right, so now after that, and it's good, okay? Okay, I guess I took care of all of them. So be very careful about those restricted domains here for the different functions here. All right, so now last one's here. Let's take a look at the inverse cotangent function. So you might want to write this in a summary table, so you will be able to remember what is the, or if you, just kind of remember the graph, then you will be able to do it, right? So let's take a look at cotangent. So this is a pi over 2, pi, 3 pi over 2. This is negative pi over 2. Okay, so cotangent is to go like this. Okay, so here, so this is negative pi. So if you remember the cotangent graph, it's to go like this. Okay, so this is my cotangent graph. Okay, and then this is, if you continue, this is the graph going to continue like that. right? So this is a cotangent graph, right? Okay, so now the cotangent is from the negative infinity to infinity. Oh, this one is pretty good. I said, oh, well, I can restrict in here. If I restrict in here, what happens here? Hey, I cover the whole range for the cotangent from the positive infinity to the what? To the negative infinities, right? So I can say y is equal to the cotangent x here. So where is my restriction here? My x is from 0 to pi, right? So this will be the domains here, right? Those will be what we call is restricted domain. That means if you want to find the inverse function, then you have to be in here. So as you can see, for this 6 different trig function, they do have a different restricted domain. So when you try to find the inverse values here, that's what are the value will be default to those numbers. So if you use your calculator, and your calculator will find, because this is the most commonly used restricted domain. So the calculator was built in this way. So when you type in like a sign, like the arc sign -1/2, your calculator will give you is the -pi/6 because the domain was built in for the restricted one is -pi/2 to pi/2 for the arc sign here. All right. Okay, so that's it. It's very interesting, the sections. And so like I say, the key things here to remember is each one, they do have a different restricted domains, right? So also understand why we want to have a restricted domain. It's because of what? It's because I have to have a one-to-one function, right? In order to define the inverse. For the periodical function, I cannot. So that's why I need to have the restricted domain to do that. All right, that's it. It's a very interesting topic. And we finished this chapter. In the next chapter, we're going to talk about how do we define the trig function from the right triangle instead of approaching from the unit circle point. Okay, that's it. Nice talk to you and looking forward to go through the next chapter with you. Okay, bye-bye.